Good morning, ladies and gentlemen. Let's talk about the difficult topic of integration by substitution. Before we have a formal discussion about the integration by substitution, let's review a few topics, if you will. So topic number one is the fact that if I have the integration of f of x dx, the indefinite integral of f of x dx, this variable x is just a dummy variable. That could be represented as the indefinite integral of f of z dz, which could also be represented as the indefinite integral of f of u du. So the variable does not matter. Example, if I have the indefinite integral sine of x dx, that's the same as the indefinite integral of sine of z dz, same as the antiderivative of sine of u du. Now, the antiderivatives will have the respective variables, but the variable is just a dummy variable. We just happen to use x a lot because we have learned from a million years that x is the horizontal, and x is the variable that is most prevalent in our study of mathematics. The other topic that I want to review, and when we talked about properties of definite integrals and properties of indefinite integrals, one of the major properties that we talked about was this notion that if I have a constant times a function, and I'm integrating the constant times this function with respect to x, of course, what I can do is I can pull that constant out and put it in front of the operator. This integration symbol, that's an operator. That's something that we operate on functions. So we can pull that constant out. We can only pull a constant out, mind you. This has to be a constant where k is a real number, where k is an element of the real numbers. But I can pull that k out and then integrate, do the operation on the particular function. That's going to be very important when I start talking about anti-differentiation or integration via substitution. And here's two nice examples. If I have the indefinite integral of sine of 7 times cosine x, that's going to be the same as if I pull that 7 out, put it out in front here, times the indefinite integral of cosine x dx. And we're going to be pulling constants out in front a lot. So we've got to get very used to seeing that we have this property that we can pull a constant multiplier out. In like manner, here's another example, if I have the indefinite integral, or if I want to find the antiderivative square root of x over 5 dx, I can see that this division by 5 is the same as multiplication by 1/5. So I can pull that 1/5. It's a constant. I can pull it out, and therefore the indefinite integral of square root of x over 5 dx is the same as 1/5 times the indefinite integral of square root of x dx. So whenever you see a constant multiplier, pull the constant multiplier out in front of the integral symbol. Okie dokie? Okie dokie. So let's go on to some integration by substitution. Let's look at example number 1. Example number 1 asks me to find the antiderivative of sine of 5 of x dx. And a lot of us are going to think, hey, that's negative cosine 5x plus a constant. The reason why we think that is because we know that the antiderivative of sine of x is equal to negative cosine of x plus a constant, because the derivative with respect to x of negative cosine of x plus c That's going to be the derivative of cosine is negative. Negative, negative makes it positive. So that is going to be sine of x, and that's where I started. I want to end up where I start. Anti-differentiate, differentiate gives me back. So I would think that right off the bat, a lot of people are going to say, hey, I got that. That's easy. The antiderivative sine of 5x dx is equal to, oh yeah, negative cosine 5x plus a constant. But when we go to check our answer, when we go to do the differentiation of this negative cosine 5x, that has to be, if this is true, if this statement is true here, if the antiderivative sine of 5x dx does equal negative cosine 5x plus a constant, then the derivative of this right here better equal the integrand. And let's see if it does. If I differentiate this, if I differentiate negative cosine, I'm going to get sine, and I'm going to have sine of 5x. But look, oh, I have to differentiate the inside, so I have to multiply it by 5. And it's clear to see, I think it is clear to see, that the sine of 5x times 5 does not equal sine of 5x. Pull the 5 out in front. 5 times sine of 5x does not equal sine of 5x. So on my original observation, this was wrong. This was not correct. This was a wrong assumption here. So we have to be very careful. And I can actually see and think about, well, what would I do? What could I add to this guy right here? What could I add to that? Or what could I multiply to that would be a better way to say that. What could I multiply to that so that when I do differentiate it, I do end up where I want it to be, which is sine of 5x. And I think it might be difficult for some of us to see that, hey, if I would have multiplied this guy up here times 1/5 and had that 1/5 here, then this 5 times 1/5 would have canceled, and then I would indeed ended up with this. So the antiderivative of sine of 5x dx is equal to negative 1/5 cosine 5x plus a constant. Many students are uncomfortable with this guessing and checking and coming up with this constant on their own. So to deal with that, let's give you a formal formula to do an antiderivative where I have an inside other than just x, and that's what I'm dealing with. I'm anti-differentiating something where the inside is not x. Anti-differentiation by substitution is similar to the inverse of using the chain rule to differentiate a composite function. So let's talk about this guy right here. Let's do another guess and check. If I have the antiderivative of 2x times the quantity of x squared plus 7 to the 5th power, I'm not going to multiply this rascal out. Oh my goodness gracious, it would take forever. And I could do that. And I could come up with a polynomial and anti-differentiate the pieces, but who wants to take x squared plus 7 to the 5th power? No one, that's who. So let's just gut feeling here. Gut feeling. Again, let's guess that this antiderivative 2x times x squared plus 7 to the 5th is equal to x squared plus 7 to the 6th over 6. Why would you think that? I don't know why you would think that. But if you did think that, guess what? Let's check our answer. So what I want to do is I want to differentiate this creature and to see if I end up with my integrand. I'm going to differentiate that and see if I do indeed end up with my integrand, this 2x times x squared plus 7 to the 5th power. So if I differentiate this, the 6 is going to come down in front, and I'm going to subtract 1 from 6. But then I have to remember, don't forget to multiply by the derivative of the inside, which is 2x. And these 6's cancel. And so I have x squared plus 7 to the 5th times 2x. The derivative of c is 0. And guess what? This time I was correct in my guess, because I did indeed end up with the integrand. This is definitely this integrand. So therefore, this indefinite integral, I was correct in my guess here. And again, I will tell you, ladies and gentlemen, that this is a hard guess to get to. A hard guess to get to. But what I would like for you to do is to observe something. Observe for a moment, if you will, that, hey, what is the derivative of the inside of that guy? What is the derivative? The derivative of x squared, x squared plus 7 is this 2x. Interesting. And that's going to lead us to our first rule for integration by substitution. And here it is. If I have a indefinite integral of g prime of x of f of g of x, here's my composite function here with respect to x, that's simply going to be the antiderivative of f of u du, provided, ladies and gentlemen, provided that u is equal to this g of x. And that's why the last example worked. So if I see an integrand where I have a composite function, if I have an integrand and I have a composite function, and the derivative of the composite function is part of the integrand, what I can do is I can just look at the antiderivative of f of the inside, f of the g, which in this case is going to be f of u du. And we know the antiderivative of f of u du is capital f of u plus c. And if I look at my prior example, oh my goodness, right there it is. Here, I do indeed have u, or g of x is x squared plus 7. That's the inside. And I do see that g prime is 2x. I'm going to let u equal x squared plus 7. And that's just going to be the antiderivative of f of u, u to the 5th. And what is the antiderivative of u to the 5th? U to the 6th over 6 plus a constant. So therefore, the antiderivative 2x times quantity x squared plus 7 to the 5th dx is equal to the antiderivative of u to the 5th du, which is equal to u to the 6 plus constant, adding 1 to the 5. But I have to remember to back substitute this u in there. And what was u? U was x squared plus 7. You're going to have several problems that you should be able to recognize that will be given in this form. Say you can't recognize this form, so I'm going to give you another method. Okay. So clearly, it's close, but no banana. It's close, but no banana. So I'm going to shade this so we don't look forward. So this is the guy that I want to look at right here. I want to look at the antiderivative of 5x squared times quantity x cubed plus 4 to the 5th power dx. How am I going to deal with that? Looks like a product. I don't have a product rule. What I'm going to do is rewrite this in a way. I'm going to use some substitution and rewrite that to give me an integral that I can indeed integrate. The first thing that I'm going to do is I'm going to notice this constant 5. And I'm going to pull that rascal out in front. That's the first thing that I'm going to do. And then what I'm going to do is I'm going to look at the inside. And I'm going to see that the inside is x cubed plus 4. Look at the inside, and it's going to be x cubed plus 4. And I'm going to let the inside be u, x cubed plus 4. And I'm going to indeed take that u, and I'm going to put it in to my integrand. I'm going to take that ux cubed plus 4 and put it into my integrand. And now I have this 5 integration x squared u to the 5th dx. And now I have to get rid of, since this is in terms of u, I have to get rid of this x squared. And I have to turn this dx somehow into a du. These have got to match up. These variables have got to match up. Ooh. What I'm going to do is I'm going to continue my little differentiation problem that I've created, or I'm going to create a little differentiation problem here. Because if I have u is equal to x cubed plus 4, I'm going to differentiate u with respect to x, and du dx is 3x squared. I'm going to solve for du, and du is going to be 3x squared dx. That's going to be helpful. And here I have a product, and what I'm going to do is I'm going to rewrite this whole thing here. This is just a product, x squared times u to the 5th times dx. And I'm going to group this x squared dx together. I'm going to group it together because I can see, oh, look, I have an x squared dx over here. And what I'm going to do is I'm going to solve for that x squared dx. Right now I have a 3x squared dx, and I'm going to divide both sides by 1/3, and that says that 1/3 du is x squared dx. So that is very handy and very nice, because what I'm going to do is I'm going to put this 1/3 du, I'm going to substitute it in for x squared dx. And what does that give me? Oh, that gives me a nice little integral here that's all in u. And keep in mind I have this constant. What am I going to do with that constant? What will I do with that? Dig and dog right. I'm going to pull that constant out. 5 times 1/3 is 5/3. And now I have this very simple thing to anti-differentiate. The antiderivative u to the 5th du is u to the 6th plus 6. Keep in mind I do have this constant 5/3. So that's going to be 5/3 times 1/6 is 5/18 u to the 6th plus a constant. I have to remember to back substitute. So let's back substitute. Keep in mind this was the original integration problem that I wanted. I wanted to know what the antiderivative of 5x squared times quantity x cubed plus 4 to the 5th power dx was. And it looks like it is equal to 5/18, quantity x cubed plus 4 to the 6th plus a constant, because I back substituted my u in there. No one said that this was going to be easy, and it is not easy. So what I've done here, I'm going to zoom in where we can see the whole page. I had this integration problem that was very difficult to do. It was actually impossible to do. What I did was I created a differentiation problem to help me with the integration problem. And I used various portions of this integration, various portions of this differentiation problem, and substituted them into the integration problem to get to a point that I could indeed integrate it. So you may have to review this video a couple times. And this is not the first time. Just like differentiating with the chain rule, integrating with substitution is going to take some time. I do have another example. Let's look at one more example. Here I want to anti-differentiate x cubed square root of, pardon me, x squared square root of x cubed plus 3 with respect to x. And I can immediately see, the inside is x cubed plus 3. So that's what I'm going to let u equal, x cubed plus 3. And then I'm going to take u, put it into integrand. So I'm going to integrate x squared, square root of u dx. I'm going to group the x squared dx together. It's a product. Multiplication is commutative. And then I'm going to finish my differentiation problem over here. I have u, I'm going to create a differentiation problem. I have u is equal to x cubed plus 3. The derivative of u with respect to x is 3x squared. I have circled over here that I need to get rid of x squared dx. So I am going to solve for x squared dx. I'm going to multiply both sides by dx, and I have du is equal to 3x squared dx. I'm going to divide both sides by 3, and there I go. I have my x squared dx is equal to 1/3 du. I'm going to put that in, 1/3 du in for x squared dx. And what am I going to do? I'm going to pull this constant out in front. And so now I have a simple integration problem to do. 1/3 integrate square root of u du. I write square root of u to the 1/2. I integrate, I use my one and only rule. I add 1 to the exponent, 1/2 plus 1. I divide by 1/2 plus 1. So I have 1/3 times u to the 3/2 divided by 3/2. So I'm going to multiply division by 2/3. It's the same as multiplication by the reciprocal. So I'm going to multiply by 2/3, u to the 3/2. 2/3 times 1/3 is 2/9, u to the 3/2. And I'm going to make sure that I'm going to back substitute what my u was, which was x cubed plus 3. And I'm going to rewrite my problem. Antiderivative of x squared, square root of x cubed plus 3 dx is equal to 2/9 x cubed plus 3 to the 3/2. And here I've left a check. You can pause the video and look at your check. I'm not going to walk through the check, but you can pause the video and go through this check if you'd like. What I am going to do is give you 5 straightforward problems, 5 problems that look exactly like the problems that we went over on this video. And I would ask you, kind madams and kind sirs, to do these problems as your e-learning assignment, and you will turn these in on Tuesdays. These problems look exactly like the problems that were went over on the video. So again, you're going to need to pause the video so you can write these problems down. And all I can say to you is, it's going to be difficult at first, but eventually you will be able to do some integration via substitution. Thank you very much and have a wonderful day.